Get ready to hear about Betelgeuse, a massive red giant star that's causing quite a stir in our galaxy. Astronomers using the James Webb Space Telescope have noticed some unsettling changes with this giant star, and scientist Brian Cox has a warning for us all. So, what's going on? Are we on the verge of seeing a supernova that could change our night sky forever? Betelgeuse is a red supergiant star located in the constellation Orion. It's huge, about 764 times the size of our Sun. If you could swap it out with our Sun, its surface would stretch past Mars, engulfing Mercury, Venus, Earth, and Mars along the way. Betelgeuse is in the later stages of its life, having spent millions of years fusing hydrogen into helium. Right now, it's about 8.8 million years old, which sounds ancient for a human, but in stellar terms, it's still considered young. Its reddish color comes from its cooler surface temperature compared to stars like our Sun. While our Sun is around 5,500 Kelvin, Betelgeuse sits at about 3,500 Kelvin. Interestingly, historical accounts suggest that Betelgeuse wasn't always red. Ancient Romans and Chinese records hint it was yellow about 2,000 years ago before it turned red and was described as such in the 9th century. Another fascinating feature is its variable brightness. Betelgeuse's light changes over time, fluctuating in a pattern that astronomers have studied for years. It usually goes through a cycle every 400 days, with longer cycles lasting about 5 years, but recently, it experienced an unexpected phenomenon referred to as the Great Dimming. In late 2019 and early 2020, Betelgeuse started to dim significantly, dropping in brightness at a noticeable rate. The tricky part is that we're seeing Betelgeuse as it was centuries ago because of how far away it is, about 725 light-years. So it's tough to predict its behavior in real time. Scientists have been closely tracking these changes and using the Hubble Space Telescope to study Betelgeuse's outer atmosphere to figure out what's going on. The dimming event, linked to an outburst of hot material, raised questions about whether Betelgeuse could be gearing up for a supernova. This mass loss was much higher than usual, leading astronomers to rethink how these stars end their lives. While some believe this could signify an imminent explosion, others think it might just be a unique chapter in Betelgeuse's lifespan. Betelgeuse's fast pace through space creates a bow shock as it interacts with the interstellar medium. This movement, along with its recent changes, suggests the star might be in an unstable state. If Betelgeuse keeps ejecting mass, it might eventually shed enough material to trigger a dramatic end. The future of Betelgeuse is still a mystery. But as we watch this star closely, we might get a rare opportunity to witness a supernova and learn more about the life cycles of these giant stars and the processes involved in creating the elements that form planets and life. Stay tuned as researchers keep their eyes on Betelgeuse and what could be a spectacular cosmic event. Alright, so there's this huge red star called Betelgeuse, chilling on the edge of our galaxy, and it's acting kinda weird. Brian Cox, the famous astrophysicist, is a bit worried. Is it about to blow up in a supernova, changing the night sky forever? Let's check it out. Stars, they're born, they live, and they die in big ways. This one, Betelgeuse, has scientists and everyone else super curious. It's a gigantic star that's pretty old and red, located in Orion. It's always been interesting, but recently, things have gotten intense. We might be about to see something huge happen as it lives out the end of its life. Betelgeuse is massive, like 764 times bigger than our Sun. If it replaced our Sun, it would stretch past Mars, swallowing Mercury, Venus, Earth, and Mars. Crazy, right? Being this big means it's reaching the end of its life, expanding and cooling after burning hydrogen in its core for a long time. This star is about 8.5 million years old, which is young for a star but ancient for us. It started as a bright blue star and slowly became the red giant we see now. Stars like Betelgeuse go through crazy changes powered by nuclear stuff and gravity. It looks red because it's cooler than our Sun. The Sun's surface hits about 5,500 Kelvin, but Betelgeuse is around 3,500 Kelvin. This lower temperature means it shines with a red light, telling us a lot about what's happening inside. And get this, Betelgeuse used to be yellow. Old Roman and Chinese writings say it was yellow 2,000 years ago, but Arabic scholars called it red in the 9th century. This color change gives us clues about how the star is changing. Betelgeuse's brightness changes too. It gets brighter and dimmer regularly, which has fascinated people for ages. It has a cycle of about 400 days and another longer one that lasts about 5 years. People noticed this as far back as 1836, maybe even earlier in Aboriginal stories. What's weird is that it doesn't always follow the same pattern, which suggests some complicated stuff is going on inside. Recently, Betelgeuse did something wild, it got super dim. Scientists call it the Great Dimming. In late 2019, this star, which is usually easy to spot, started to fade, losing brightness until February 2020. Even regular people could notice it was getting fainter. But here's a tricky thing. When we look at Betelgeuse, we're seeing it as it was 725 years ago, because that's how long it takes for the light to get here. So, it's hard to know what's happening right now. This dimming event reminded us what a challenge it is to study stars in real time. Andrea Dupree at Harvard and Smithsonian and her team used Hubble to watch Betelgeuse. They were checking out its outer atmosphere, which expands and contracts, causing the star to change brightness. Hubble could see ultraviolet light, which helped them study the hot layers above the surface. They saw stuff moving at 200,000 miles per hour from the star into its atmosphere. This hot, thick stuff went millions of miles out and made a dust cloud that dimmed the star. Dupree's team said it lost twice the normal amount of material from its southern side in those 3 months. That's a lot, especially since stars lose material all the time. This made scientists wonder if Betelgeuse was about to explode. Since it's about 725 light-years away, we'd see it happen, which would be amazing. But what does this dimming mean? Is it going to explode, or is it just a weird phase? Some thought it was starting to explode since everyone thinks Betelgeuse is near the end of its life. Others figured dust was blocking our view. Red supergiants shed material, and maybe it formed a cloud thick enough to block the light. A third idea was that the star's surface was changing, affecting how bright it looked. Looking closely, scientists saw the temperature dropped, suggesting a big dark spot on the surface. Betelgeuse got about 170 Kelvin cooler when it dimmed, which is a big deal. Hubble helped solve the mystery. It turned out Betelgeuse shot out a bunch of hot stuff into space, which made a dust cloud that blocked the light. This cloud came from super hot plasma that erupted from a big spot on the star. As it moved out and cooled, it made dust grains, creating a cloud that blocked about a quarter of the star's light. Hubble saw signs of this heated stuff moving through the star's atmosphere months before it dimmed. In December 2019, other telescopes saw the star getting dimmer, especially on its southern side. This stuff, which was initially brighter, turned into a dark cloud as it moved out and cooled, causing the dimming. Betelgeuse shot out a massive amount of stuff, like 400 billion times what a normal star throws out. This material weighed several times as much as our moon. So, what does this mean for Betelgeuse and the supernova theories? Usually, red supergiants steadily shed mass before they explode. But this event suggests it might be a more chaotic process. Could Betelgeuse be getting ready to explode in the next few thousand years, or maybe even in a few decades? Also, Betelgeuse is moving through space super fast, creating a bow shock, which is similar to the wave a ship makes. This happens as the star's outer layers hit the gases and dust in space. Studying this bow shock tells us about Betelgeuse and helps us understand how stars lose mass. After the ejection, Betelgeuse's surface cooled and became less thick, leaving it unstable. Computer models show that the star's activity, the mass ejection, and changes in how it pulses are all connected. This instability makes us wonder what's going on inside and how it will end. Betelgeuse is losing mass faster than other stars, which suggests something complicated is happening inside. If Betelgeuse keeps pulsing and throwing out mass, it could eventually shed enough to explode in a supernova. This would be a huge burst of energy that we could see from far away, giving us a great look at the end of a giant star. Since Betelgeuse is acting so strangely, what will happen to it is a big question in astronomy. If Betelgeuse turns into a supernova, we'll get valuable info about what happens to stars as they die. Watching stars like Betelgeuse is helpful because it lets scientists study the final stages of big stars, which is key to understanding how heavy elements, like the ones that make up planets and us, are formed. As it gets closer to becoming a supernova, Betelgeuse will keep changing. Its outer layers will get more unstable, and it will get brighter and dimmer. It might shoot out a bunch of gas and dust, which is not only pretty but also helps create new stars and planets. Studying Betelgeuse could also show us how stars affect their surroundings. It's moving so fast that it might hit different spots of gas and dust, which could change how it releases energy. These interactions could create shock waves, making things even more complicated and interesting. Will this dimming and mass ejection make it explode sooner? Some scientists think so, while others think it will take longer. No matter when it happens, Betelgeuse shows us how much we still need to learn about stars and the universe. As telescopes like Hubble and Webb keep watching Betelgeuse, we hope to learn more about how stars live and die and maybe the formation of elements, galaxies, and even life. Okay, so there's this star, Betelgeuse, a red giant on the edge of our galaxy, acting weird. Astronomers using the James Webb Space Telescope spotted something strange, and Brian Cox is giving us a heads up. Is it about to blow up in a supernova, changing the night sky big time? Let's get into it. Stars live and die spectacularly, and Betelgeuse has been grabbing attention. It's a huge, old red supergiant in Orion, known for its reddish color and changing brightness. But things have been getting intense lately. Are we about to see something huge happen? Betelgeuse is about 764 times bigger than our Sun. Seriously, if it were in our Sun's spot, it would swallow Mercury, Venus, Earth, and Mars. It's in its final stages, expanding and cooling after burning hydrogen for millions of years. It's like 8.8 to 8.5 million years old, so it is pretty old for a star. It used to be a hot blue star, but now it's this red giant. Stars like Betelgeuse change a lot during their lives, thanks to nuclear fusion and gravity. Its red color is because it's cooler than our Sun. The Sun's surface is about 5,500 Kelvin, but Betelgeuse is around 3,500 Kelvin. This cooler temp makes it look red. What's odd is that Betelgeuse seemingly changed color a bit. Ancient Roman and Chinese records say it was yellow 2,000 years ago. By the 9th century, Arabic folks called it red. It also flickers in brightness. It's a semi-regular variable star, dimming and brightening every 400 days or so, with a longer cycle of about 5 years. People noticed those cycles way back in 1836, and maybe even earlier by Aboriginal people. Its brightness is a bit jumpy, not very predictable, which means there's something weird going on inside it. Recently, Betelgeuse did something really strange. It went through what people now call the Great Dimming. In late 2019, it started getting dimmer fast, losing brightness until February 2020. You could barely see it, even though it's normally easy to spot. Here's the thing about looking at stars, you're seeing them as they were. Betelgeuse is 725 light-years away, so the light we see today left the star almost 7 centuries ago. It's hard to keep an eye on stars when you are looking into the past. Andrea Dupree at Harvard and Smithsonian and her team was watching Betelgeuse closely. They checked its outer atmosphere with Hubble as part of a 3-year research to monitor changes. Hubble's ultraviolet light helped them see what was happening above the surface, where things get heated by the star's convection cells, kind of like how water boils. The spectra showed stuff moving like crazy, about 200,000 miles per hour, from the surface, and that's how they measure it. This hot, thick stuff went millions of miles out and made a dust cloud that dimmed the star. Dupree's team thinks Betelgeuse lost double the mass it normally does from its southern side in those 3 months. Now, all stars lose mass, but Betelgeuse loses way more than our Sun. All this mass flying off made astronomers think about a supernova. Since Betelgeuse is relatively close, about 725 light-years away, we'd see it go boom. But is that what the dimming means? Is it about to blow, or is this just another weird thing it does? A few ideas popped up. Maybe it's starting to go supernova. Another idea was dust, maybe from the star itself, blocking our view. Some thought it changed its photosphere, the surface we see, which changed its brightness. Turns out, Hubble helped crack the case. The dimming was most likely from hot stuff shooting into space, creating a dust cloud that blocked the light. It probably came from superhot plasma erupting from a convection cell, then cooling down and forming dust. The dust cloud blocked about a quarter of the star. They figure this material shot out and formed a dark cloud, so it caused the dimming. Betelgeuse really put on a show. It threw out about 400 billion times more mass than a normal mass ejection. This stuff weighed several times as much as our moon. Could Betelgeuse be getting ready for a supernova soon, like in the next few thousand years? Some think it could be as soon as the next few decades. Also, there's this thing called a bow shock. Betelgeuse is zooming through space at about 67,000 miles per hour. As it moves, the interaction with interstellar gases creates something like the wake of a ship. It's all useful for knowing where Betelgeuse is now, stellar growth, and how mass changes. Since the ejection, Betelgeuse's surface has cooled down and thinned out, leaving it unstable even now. Simulations connect the star's convection, the mass ejection, and changes in how it pulsates. All this makes you wonder what's driving this and how it ends. If Betelgeuse keeps this up, it might lose enough mass to go supernova. It would be super bright and visible from really far away. So, Betelgeuse is still acting strangely, and what happens next is anyone's guess. Figuring out its fate is a hot topic for stargazers. If it blows, we'll get to see a star die up close, which would teach us a lot. Watching stars like Betelgeuse helps us learn how heavy stuff, like the stuff that makes up planets and us, gets made. Before a supernova, the physical features of Betelgeuse will keep on changing. In the last few stages of its life, its outer layers will get more and more unstable. This could lead to more extreme burps, throwing even more gas and dust into the area. These actions help enrich the space around it to form more stars. How these stars react with each other can be a bit more complex. Knowing how fast Betelgeuse goes versus its mass, density, and speed allows us to gather details on shock waves, medium materials, and surrounding dust. Will this dimming and mass ejection lead to a sooner than expected supernova? Some astronomers believe the star could keep growing at its own pace. Telescopes like Hubble and Webb keep watching it, and hopefully, we'll learn even more stuff about stars, components, and element composition.